China is building an airport in the ocean. Not near the ocean, not on the coast. In the ocean. 20 square kilometers of artificial land manufactured from scratch in open water on a site where nothing but sea existed before. The project is called the Dalian Jinshawan International Airport. When completed, it will be the largest artificial island airport ever built on Earth. Bigger than Japan's Kansai. Bigger than Hong Kong's Cheklap Coke. Bigger than both of them combined. The island alone will be larger than the entire country of Monaco. It will have 4 full-length runways, capacity for 80 million passengers per year, and the ability to handle 1 million tons of cargo annually. The estimated cost is $4.3 billion. And it is being built in one of the most hostile marine environments in Asia, a bay where typhoons, winter sea ice, and earthquakes all converge on the same patch of water. No country has ever attempted an offshore airport project at this scale, and no country except China would have a reason to try. Before we talk about how they are building it, we need to talk about why. Because nobody spends $4.3 billion to put an airport in the ocean unless every option on land has already failed. Dalian is a coastal city in northeastern China, tucked between the Yellow Sea and the Bohai Gulf. It is home to more than 6 million people. It is one of the most important logistics and shipping hubs in the country. It sits just a few hundred kilometers from South Korea and Japan, which makes it a strategic gateway to Northeast Asia. And its existing airport is a problem. The current Dalian Jinshawan International Airport was built decades ago when the city was smaller and the surrounding land was still undeveloped. Since then, the city grew around it. Dense residential neighborhoods now press against the airport perimeter on multiple sides. Hills and unstable terrain block expansion in the remaining directions. There is physically no room to add another runway. There is no room to build a second terminal of meaningful size. The airport is boxed in by geography and urbanization, and it has been operating near capacity for years. The planners face 2 options. Option 1, move mountains. Literally, flatten the hills surrounding the existing airport, relocate entire neighborhoods, and try to carve out enough space for expansion in terrain that is geologically unsuitable for heavy infrastructure. That would take decades, cost billions, displace tens of thousands of people, and might not even produce enough usable land for a modern 4-runway hub. Option 2, move into the sea. Build new land where no land exists, 25 kilometers from downtown, in Jinshawan Bay. Start from nothing. Design from scratch. No neighbors to relocate. No hills to level. No geological constraints inherited from existing terrain. Just open water, a blank canvas, and every engineering challenge the ocean can throw at you. China chose the ocean. And to understand what that choice means in practice, you need to understand what the ocean in this particular location is actually like. Jinshawan Bay is not a calm tropical lagoon. The water reaches depths of up to 10 meters across the construction zone. The region is hit by powerful typhoons during summer and autumn, storms that drive waves up to 8 meters high and carry enough force to destroy conventional coastal structures. In winter, the bay freezes. Sea ice forms across the surface, and the expanding ice exerts enormous lateral pressure on anything standing in the water, pressure that can crack concrete, shift foundations, and buckle steel reinforcements. And underneath all of that, the seabed sits within a recognized seismic zone. Earthquakes are not hypothetical in this region. They are a design parameter. Any structure built here must survive storm surge, ice loading, and seismic events, not as unlikely worst-case scenarios, but as expected operating conditions across the airport's lifetime. China is not the first country to build an airport on an artificial island. Japan did it in 1994 with Kansai International Airport in Osaka Bay. Kansai was a groundbreaking project and an engineering landmark. It was also a warning. The artificial island that Kansai sits on was built on soft marine clay, the kind of saturated, compressible soil that behaves more like wet sponge than solid ground. Almost immediately after construction, the island began to sink. In the first few years, parts of the island sank by more than a meter. Engineers had anticipated some settlement, but the rate and unevenness of the sinking exceeded projections significantly. Some areas sank faster than others, creating differential settlement that threatened to crack foundations, misalign runways, and damage underground utilities. Japan spent billions on remediation, installing over 1 million sand drains to accelerate the consolidation of the clay beneath the island, building adjustable columns under the terminal that could be individually raised or lowered to compensate for uneven ground, and continuously monitoring thousands of survey points across the island to track movement in real time. 3 decades later, Kansai is still sinking. Slowly, manageably, predictably now, but still sinking. The terminal floor has been adjusted multiple times. The airport works. It handles millions of passengers. But it taught the world an uncomfortable lesson. The ocean floor does not behave like dry land, and building on it means committing to a permanent relationship with instability. Hong Kong's Chek Lap Kok Airport, opened in 1998, took a different approach. Instead of building on soft clay, the project leveled two entire islands, Chek Lap Kok and Lam Chau, flattened them into the sea, and used the material to create a single flat platform large enough for 2 runways. The engineering was more aggressive, the terrain was harder, and the design was shaped around one non-negotiable requirement: survive a direct typhoon hit. Chek Lap Kok has done that repeatedly. It is one of the most successful airport projects in history, but it required destroying 2 existing islands to build one new one. Dalian's project faces both of these challenges simultaneously and adds new ones. The island will be bigger than Kansai and Chek Lap Kok combined. The environmental conditions are more extreme. Typhoons plus sea ice plus earthquakes is a combination neither Japanese nor Hong Kong engineers had to design for at the same time. And unlike Hong Kong, there are no existing islands to level. Every cubic meter of the Dalian Island has to be manufactured from raw materials and transported to the site by barge. According to available reporting on the project, over 400 million cubic meters of sand, rock, and engineered fill material are being shipped to the construction zone. That is an almost incomprehensible volume. It has been compared to enough material to bury the city of San Francisco under 30 meters of earth. And none of it can be dumped randomly. Each load must be precisely placed, layered, compacted, and stabilized to create ground that behaves like natural bedrock, even though it is entirely artificial. The construction site on any given day looks like a floating industrial city. Dozens of barges line up to unload sand and rock. Crane ships position concrete blocks along the seawall perimeter. Dredgers pump sediment from designated extraction zones through pipelines to the island footprint. Compaction equipment rolls across the freshly placed fill, pressing it down layer by layer to eliminate air pockets that would cause future settlement. Workers monitor water levels, soil density, and fill height continuously using GPS survey equipment mounted on the machinery. The precision required is extraordinary for something that looks from a distance like dumping dirt into the ocean. Every layer has to meet specific density and moisture specifications before the next layer goes on top. Get it wrong, and the ground shifts under the weight of a loaded aircraft 10 years later. The engineering techniques being used to achieve that are industrial-scale versions of methods developed over decades of marine construction. Deep cement mixing involves injecting a cement slurry into the soft marine soil beneath the island, creating columns of hardened earth that act like underground pillars. Thousands of these columns are drilled through the seabed to stabilize the foundation. Pressure grouting binds the fill layers together by injecting high-pressure cement between the compacted materials, filling voids, and creating a continuous rigid mass. Driven piles, steel or concrete columns hammered vertically into the seabed, some extending more than 80 meters deep, anchor the island to the harder geological layers far below the ocean floor. Together, these systems create a man-made bedrock that is engineered to remain stable under the combined loading of 4 runways, multiple terminals, fuel systems, cargo facilities, and the constant vibration and impact of commercial aircraft operations. Around the perimeter of the island, fortified sea walls are being constructed to protect the artificial land from the ocean. These are not simple concrete barriers. They are complex layered structures incorporating steel reinforcement, interlocking concrete blocks, and tetrapods, those distinctive four-armed concrete shapes designed to break wave energy before it reaches the wall. The same type of breakwater structures used on military coastal installations and missile defense islands. The sea walls are designed to withstand direct hits from waves up to 8 meters high, and to resist decades of saltwater corrosion without catastrophic failure. The ocean doesn't stop pushing. The walls have to push back every day for the next 100 years. But building an island in the ocean does not just raise engineering questions. It raises environmental ones. Reclaiming 20 square kilometers of seabed is not a neutral act. It destroys the existing marine habitat on the ocean floor, the organisms, the sediment structures, the ecosystems that developed over centuries in that specific patch of water. It disrupts sediment flows that feed coastal ecosystems along the adjacent shoreline, potentially eroding beaches and changing the shape of the coastline itself. It can alter tidal patterns, water temperature, and nutrient distribution in ways that affect marine life far beyond the construction zone. Fish populations that relied on the bay for spawning or feeding lose their habitat permanently. The ecological cost is real, and it is paid up front, before any airplane lands. The project's environmental mitigation plan reportedly includes artificial reefs designed to replace lost habitat, transplanted marine vegetation moved from the construction zone to protected areas, carefully modeled tidal channels that preserve water circulation around the island, and real-time environmental monitoring systems that track the ecological impact over time. Whether those measures are sufficient to offset the damage of erasing 20 square kilometers of ocean floor is a question that marine biologists will be studying for decades. The construction is proceeding while the answer is still being measured. And then there is the connection problem. An airport is useless if people cannot reach it. The Dalian Jinshawan site sits approximately 25 kilometers from the city center and roughly 18 kilometers from the current airport. That is not walking distance. For comparison, most major airports sit within 15 kilometers of their city center. 25 kilometers over water with a bridge or tunnel in between creates a logistical barrier that could undermine the entire project if not solved properly. An island airport with poor ground connections becomes an expensive inconvenience rather than a transportation hub. Passengers choose to fly from competing airports rather than deal with a long, difficult journey to the terminal. The project plan includes elevated roads and bridges linking the island to the mainland, extensions of metro lines to provide direct rail service to the terminal, shuttle bus networks, public transit hubs, and a fully integrated multimodal transportation station designed to move tens of millions of passengers per year between land, rail, road, and air. Metro Line 5 is reportedly already under construction, with Line 1 being extended to reach the airport. The goal is to make the 25-kilometer journey from downtown Dalian to the terminal feel seamless rather than remote. Whether the transport links will be finished in time for the airport's opening, and whether they will have enough capacity to handle 80 million passengers per year, remains an open question. Now let's talk about what this airport is really for. Because a city of 6 million people does not need an 80 million passenger airport. Not for domestic travel, not for regional tourism. The numbers only make sense if the airport is designed to serve a function much larger than Dalian itself. Dalian sits at the geographic crossroads of Northeast Asia. South Korea is just across the water. Japan is a short flight away. Both are among the largest economies in Asia and major trading partners with China. An airport positioned here with 4 runways, massive cargo capacity, and direct rail connections to China's national network is not just an airport. It is a logistics gateway, a node in a much larger infrastructure strategy. Officially, the Dalian Jinshawan Airport is part of China's civil aviation expansion program, but its scale, location, and design align closely with the Belt and Road Initiative, China's long-term strategy to connect global trade through infrastructure. Airports, ports, rail lines, and highways stitched together across continents to reshape the flow of goods, people, and influence. Dalian's new airport fits neatly into that network. A hub where air cargo from Northeast Asia connects to rail freight heading west across China and into Central Asia and Europe. A point where international passenger traffic feeds into China's domestic high-speed rail system. A facility designed not just to move people in and out of Dalian, but to route them through Dalian as part of a larger continental logistics chain. And then there is the question that almost every analysis of Chinese artificial island projects eventually raises: dual-use capability. The term means infrastructure that serves both civilian and military purposes. For runways capable of handling the largest commercial aircraft are also capable of handling military transport and surveillance aircraft. Massive cargo facilities designed for commercial freight also support military logistics and rapid deployment. A fortified artificial island in a strategic maritime location provides options that a conventional inland airport does not. This is not speculation without precedent. China has built artificial islands in the South China Sea with runways and military installations on disputed territory. Those projects were framed initially as civilian or scientific, then expanded into strategic military assets. Nobody is publicly claiming that Dalian's airport is a military project, but the capability is inherent in the design. And in infrastructure planning at this level, capability and intention are often separated by nothing more than a policy decision. The first phase of the project is expected to be completed by 2035. At that point, the airport would handle approximately 43 million passengers per year, roughly comparable to John F. Kennedy International Airport in New York. If the full 4-phase plan is realized, capacity would grow to 80 million passengers and 1 million tons of cargo annually. That would make it one of the 10 busiest airports on Earth. More cargo than London Heathrow, more passengers than Los Angeles International, built entirely on land that did not exist. But none of this is guaranteed. At $4.3 billion, the financial risk is enormous. If the island experiences unexpected settlement, The kind of sinking that plagued Kansai for decades, remediation costs could push the total far beyond the original budget. If the projected passenger demand does not materialize, if airlines choose other hubs, if geopolitical tensions redirect traffic, if the economic growth of Northeast Asia slows, the airport could become one of the most expensive, underperforming assets in aviation history. China has built mega airports before that operate well below capacity. The risk is real, and there is the Kansai lesson. The ocean does not stop. The waves do not take a year off. The ice does not skip a winter. The seismic fault does not wait for the construction to finish. Every year, the sea tests the island. And every year, the island has to pass. There is no version of this story where the airport is built and the engineering is finished. The engineering is never finished. The ocean makes sure of that. What China is attempting in Dalian is not just building an airport. It is manufacturing geography, creating land where there was none, designing ground that must behave like bedrock while sitting on the ocean floor in 10 meters of seawater. Building a transportation hub that connects air, rail, road, and sea on a platform that has to survive typhoons, ice, and earthquakes simultaneously for a century or more. And doing it at a scale that no country has ever attempted and most engineers thought was impractical until the barges started arriving. That is either the most ambitious infrastructure project of the decade or the most expensive lesson in overreach the aviation industry has ever seen. The answer will take until 2035 to arrive, and by then, the ocean will have already been testing the island for years. Every winter's ice will have pushed against the sea walls. Every summer's typhoon will have thrown waves at the runway foundations. Every tremor from the seismic zone below will have sent vibrations through the piles that hold the whole thing up. The engineers who designed this airport are not betting that the ocean will be gentle. They are betting that they built something strong enough to take whatever the ocean delivers. That is a bet measured in decades, not years. And the ocean has never lost a long game against anything humans have built. It just takes its time. 20 square kilometers of artificial land. For runways. 80 million passengers. For $0.3 billion. Built in a bay where typhoons, sea ice, and earthquakes all share the same address. And the country building it looked at all of that and said yes. The ocean didn't get a vote.